Okay guys, I'm really excited. I'm standing next to our 292 inline 6-cylinder Chevy, the other guy's motor, and it has a turbo. And I've got good news and I've got bad news. First, the good news. We ran boost, and when we ran boost, it got better, and when we ran more boost, it got even better. We added an intercooler, and it got even better, and pretty soon we had better stacked on top of better and stacked on top of better, and pretty soon the whole world is better because everything is better with boost. Here's the bad news. The thing that I chose to make that boost. This 76mm turbo from CXRACING is not ideally suited to this motor. Unfortunately, it's a little on the big side. It's designed to make 700 horsepower. It has a history. We use it as a big bang motor in twins, and it worked very well. But on this motor, it's not ideal. And unfortunately, the other smaller turbos that I had were all T3 based, and I didn't have a T3 flange for this, so I was forced to run this turbo. But more good news, it worked fine. It made lots of boost. It just wasn't as responsive as I'd like it. But you have to wait till the end to find out. How did we almost double the power output of our NA motor at only 10 pounds of boost? That's right, you heard me right. I'm ready to blow some minds. Were you using liquid nitrogen? What were you doing? How did you almost double the power output at only 10 pounds of boost? Stick around the end and find out. About a medium amount of sludge in here. All right, time to take the Dominator off and put the turbo on. I've got the pan on. We've removed it, took it off. Got the drain for the turbo on. Time to install the turbo kit. So we've got the Dominator off. We're just left with the 2-barrel adapter for the Holly because that's what we're going to run. Now we'll remove the headers so we can put the stock exhaust manifolds back on. Oh wait, I need to correct myself. Not stock exhaust manifolds, I mean custom turbo manifold. So we'll take the O2 sensor out, take the headers off, and then put the stock manifold back on. Dang it, turbo manifold. So when I did this original design, I forgot about something very important, and that is the wastegate, which every turbo system needs. But no worries, I've got this piece, wastegate mount, turbo mount, it'll all work out good. Well, my turbo was originally supposed to mount here, which would have put it a little closer, and I would have been better, but right here, to the rescue, that little piece, got my adapter. It's a little farther out than I want it, but you know what? For what I'm doing, for as long as it has to run, it's gonna be just fine. Okay, we're gonna put the carb bonnet on here, got our 2-barrel up, got our offset mount. So now what we gotta do is duct from our turbo over into here. Bingo. The goal, as always, for any kind of boosted combination I'm gonna run on the engine dyno is to put together the discharge and the exhaust section, including an intercooler if I'm gonna run one, using the existing stuff that I have. I don't wanna cut and weld and make some sort of dedicated piece just for the dyno and then to have to take it all apart. So this way, if I can just hose clamp it all together using the stuff I have, that's a win. So that's what I'm going to do right here. All I got to do is connect this turbo to this, and we're all good. And then I might try an intercooler later on. Let's do it. See, this is what I'm talking about reusing stuff. This is actually from a Torque Storm supercharger. So it's a discharge or a blow-off valve. And I'm going to run this here because I think it's going to work. 3-inch jet clamp it. There we go. Okay. I have to orient the turbo just a little bit for that, but I think we can make it work. Sweet. Okay, so I need to change the orientation of this just down just a little bit. That's not a problem. Just loosen the last bolts on our turbo. Angle that down. Now, see if we can fit this in there. Okay. Get our clamp on there. Get our final clamp on here. Slide it on there. And a piece of tubing might be just a little bit short. We'll have to see. I think we can make it work. Okay, it's going to be a little bit on the sketchy side, but that's all right. That's how we like it. And tighten our turbo. Click, click. I did the right amount of clicks on that one. Click, click. Sweet. Put our clamps on. It's not wanting to cooperate right now. No cooperation. See? Why aren't you being like more like that? That one's all good. That one's all with the program. Look, that's how it's supposed to work. When you're a clamp, that's what you're supposed to do. You're supposed to go on there, clamp, and have fun. What's that? What's that? What are you saying? I'm supposed to put the right size clamp on there? Great. Come on. Last thing I need is attitude for a hose clamp. You're going on there. That's right. All right. Time for some vacuum lines. Everyone wants to know the specs on the turbos we run, and quite honestly, this turbo, I didn't pick it because it's optimally suited for this combination. The only thing optimum about it is its optimum placement over in my stuff so I could walk over and grab it and put it on. It's more of a convenience thing. But this particular turbo is interesting. It has a history. It's one of the ones that I use for the Big Bang. It's a CXRACING 76mm. I'm going to show you the part number because it happens to be stamped on this one so you can find out more information about it. Look. Spinny stuff. Ooh. Ah. But take a look. Here we go. I'm going to zoom in. TRB T76 P96 serial number. Look at that. This is famous. It's up. Here's something that's very important to understand. It's about providing a boost reference to the fuel pressure regulator. You have about 6 or 7 pounds of fuel pressure flowing into the carburetor. But if you're adding 6 or 7 pounds of boost into the carburetor, there's not going to be any fuel flow because you're going to have 7 pounds fighting 7 pounds, and that equals 0. So what we do is we run a reference line here off of the hat because we want the response rate. We run that to our regulators down here. So it's going to add how much ever boost pressure there is to the fuel pressure. So we'll always have a delta of about 6 or 7 pounds. So that means we will always have fuel flow going to the carburetor even under boost. And then it just comes down to jetting and stuff. I know what you're thinking. Hey, Richard, are you crazy? That's not a dedicated blow-through carburetor. But we're going to find out whether or not it works. I'm going to have Kevin build this one up, but he hasn't done that yet because this is it right here, and I haven't given it to him, so that's on me. We're going to find out if it works. I'm going to try to jet it and stuff and see if we can make it work. We're going to turn it into a blow-through carburetor. Okay, the good news is I got the turbo system all hooked up, but there's also bad news. So how much were you guys paying attention when I was putting this together? Can you tell me what's wrong with this picture and why that we wouldn't want to run this right now? We've got our oil lines on, we've got our exhaust on, got the O2 sensor in, we've got all of our boost reference stuff on. But what's the matter with this picture? Yep. No flipping wastegate. When I reconfigured it basically the same way as I had it with no wastegate. So now I got to reconfigure once again. So how many of you guys guessed it right? How many of you guys saw that? How many of you guys were yelling at me saying, hey, yo, where's the wastegate? I'm going to configure this Turbo Smart wastegate. It's a Hypergate 45. I'm going to put a spring in it. It just screws off. Set that in there. That's a 7-pound spring. Ta-da! Here is new turbo kit version 2.0. Okay, I know, it's version 3.0. Why you gotta judge me? Come on, man. Judge me, Judgerton. Okay, turbo has U-bend, which will also allow possibly the placement of an intercooler into our blow-off valve, into our bonnet, into the carburetor. Here's our wastegate, and yes, I know there's no wastegate reference line hooked up. There will be. I don't know, we're getting close. If you guys aren't getting excited, okay, during our run, we started getting misfire after we turned the boost up a little bit, and I'm going to take these plugs out. I've already checked the gap. This one's out around 40,000, so if we bring this down about 20, I think we'll have much better luck. So I'm going to try that and see, but we might be getting near the limit of this this point cell ignition. I haven't even changed the points yet. They're all still the factory ones that originally came with this motor when I got it from Freiburger. So all that stuff is kind of questionable. I also have an MSD coming, a distributor that I can hook up to the 6AL ignition amplifier. That should cure any problem. But I kind of want to see how far we can take this, so let's gap them plugs. So here's how I do it. Lots of guys do it a lot more professional. Boom, done. Gappy gap. Okay guys, we've made a bunch of runs in non-intercooled and we're all the way up to like 6.5 pounds. Even though we're not running very much boost, I want to go ahead and put an air-to-water intercooler on, the same one we always run from ProCharger. I want to see if there's any power to be had even at that boost level, and then we'll turn the boost up just a little bit more. I don't know how far we can go with the factory ignition, but we'll find out. I'm not going to turn it all the way up right now because I have some other mods I want to do to it. But, because you guys always ask, I wanted to let you know, it's run on pump gas. It's got 25 degrees of total timing. I don't have the vacuum advance hooked up. It's just running the centrifugal advance. 25 degrees total, and I changed the jet in our 2-barrel carburetor. Remember, it's just a Holley 2-barrel. It's not a dedicated blow-through carburetor. it's just a carburetor that I'm blowing through. But we did have to change the jets. It comes from the factory with 74 jets, and I'm all the way up to 96 jets to get the air fuel that I want, because I want the air fuel to be in the 11s, in the mid 11s or so. And it starts out a little bit leaner and then transitions rich. I'll go ahead and show you guys the air fuel curve. I'll put it up here so you guys can look at it. But that's how we're running right now. So I'm gonna go ahead and put the air-to-water intercooler on. Awesome stuff, boosted 292. As you can see, a bit of change, got an upgrade, boost, fun stuff goes in there, funner stuff goes in here, and super amazing stuff comes out and goes into there. Carburetor cools it even more, it's awesome. Let's see what happens when we run intercooled boost. Turn the little knob on these controllers and good things happen. Obviously I got to bring in dyno results on all this, and this was our 292 inline 6-cylinder Chevy, and we ran it NA, and this was with the stock exhaust manifolds, but with the Holley 2-barrel carburetor, because that's the carburetor we used when we ran it under boost. It made 156 horsepower, and you can see torque was way up here, although that's the load-in number, but still, over 250 foot-pounds of torque. What I'm going to do is I'm going to get rid of torque for right now when we start talking about the turbo stuff, because it'll be easier to understand if I just have one up there at a time. So here's what happened when we got things started. We ran 5.3 pounds, no intercooler. We ran 25 degrees of timing, and air-fuel ratio started out at about 11.9 and then went down to 11.1 about. I'll show you those curves too. Here's what happens when we added the turbo. Power picked up from 156 up to 227. And as you can see, the gains increased with RPM, and the reason for that I'll show you is because of the boost curve supplied by that turbo. It was not very responsive on this combination, and a smaller turbo would definitely give us better response, and we'll make sure we do that next time. But here's what happened after we increased the boost, still non-intercooled. Oh, I take that back. We added the intercooler and went up to about 7 pounds. 261 horsepower, and notice our gains are kind of happening late in there, because when we adjust the manual wastegate controller, we're only getting gains, you know, when the wastegate is actually activating, and it's not, because we're still coming up on the boost curve here. So here's what happened after we increased the boost up to 10.1 pounds. And again, up over 300 horsepower, 307 horsepower, so it was working well. But again, we only saw the gains at the very top because we weren't at the point where the wastegate was holding things back. So now let's take a look at the torque curves. So now you have an understanding of what's going on. Our boost wasn't very responsive on that particular turbo. Now let's take a look at the torque curves. This is the torque provided by our naturally aspirated 292 inline 6-cylinder Chevy. You know, 258, although that's a load-in point. You know, I think I went over that. It's anything over 250 is pretty nice for that. So here's what happened to the torque curve when we added 5.3 pounds on our turbo setup here. Right at 300 foot-pounds, 299.3. But that peak was occurring out at 3750, which is closer to where the horsepower peak was when this thing was NA. So we just didn't have any boost, and I'll show you the boost curve down here. Otherwise, you know, we're talking about almost doubling the power output. I see no reason why we couldn't have come close to doing that with torque as well. So, you know, if we're starting out at 250, I'm sure that we would have been up near 500 if we had a nice flat boost curve. But that's 5.3 pounds. Here's what happened when we ran 7 pounds with the intercooler, 331.5 foot-pounds of torque, and you see it occurred even later at 4,000 RPM because we had a rising boost curve. So here's what happened when we ran 10.1 pounds, 352 foot-pounds, but again, it's happening way out there pretty late, now at 4,500 RPM. So that's our torque curves. Now let's take a look at the boost curves and you can see what I'm talking about. So here's the boost curve provided by our turbocharged 6-cylinder. Peak boost of 5.3 pounds, but look down here at 2,500 where we're loading this thing in. We only have like 1.5 pounds of boost. Here's what happened when we increased the boost to 7 pounds. You know, we got gains, you know, past 3,500, 3,600, and we had more boost up here at the top. Same thing happened when we went up to 10 pounds. You know, the peak gains at the top. It almost looks like the boost curve from a centrifugal supercharger. Again, the turbo was just not sized right for this combination, and a smaller turbo, more efficient turbo, something that wants to make, you know, 300, 350 horsepower would be really good down here. And so if we had a consistent 10 pounds of boost, we'd have a lot of torque. But hey, it's another test for another day. Here's something else I wanted you to look at, and this is the air fuel curve provided by our 2-barrel Holley. This was on the naturally aspirated one. Started out fairly lean, transitioned down here to 12.0 and NA, and we tried playing with jets a little bit, and this turned out to be the best like average combination we could come up with. Here's what happens when we ran the turbo blowing through this with, what did I say, 95 or 96 jets on it finally. This is non-intercooled. Same kind of thing. Gets richer as we go. Starts out at 11.8. Ends up at 11.0 or 10.9. That's at 5.3 pounds. And we didn't make any jet changes after we started turning up the boost. We just kept with the same jetting. So here's what happens when we went to 7 pounds. Not a big difference. Started out a little bit leaner. It was making more power there. Once we added the intercooler picked power up. But again, it just transitioned down to being rich. Down to 11.2. Here's what happened when we went up to 10 pounds. Similar kind of thing. A little bit richer there. Started out at 11.5. And again, transitioned down to 11.0. So obviously we can't go in and adjust those individually on a blow-through carbureted application. But, you know, it worked out pretty good. It was nice and safe. And, you know, everything worked out good. Let's get to our conclusion. Okay guys, this is what you stuck around for. I told you to stay to the end, and now I'm going to tell you, how did we almost double the power output of our 292 inline 6-cylinder Chevy with what is admittedly the wrong turbo at only around 10 pounds of boost, 10.1 to be precise. How did we do that? Well, the reality is we really didn't do that. I mean, and by that I mean the NA motor was already restricted by the size of the orifice in the intake manifold. We know that because when we put a 2-barrel carburetor, the power went up. And if I would hog out that hole, it would get even better. And if I put 2 holes in it or multiple carburetors, we would definitely make more power. So when we added the turbo and we're forcing air through that hole, we artificially make it way better than it is. Way better than it was when it's naturally aspirated. So we're really only doubling the power output, or we're not doubling the power output of a combination that should be there that really isn't because it's way too restrictive. Thanks for watching, guys. Hope you like this 292. I got a lot more stuff coming up with it. I'm going to put a cam in it. We're going to port the head. I'm going to put the right size turbo on it. We got a lot of cool stuff. I mean, this is just the tip of the iceberg. There's a lot more power left in this 292, and I'm going to go find it.